In this lesson, we will examine some techniques for solving challenging questions involving inequalities. The first technique is combining inequalities. In this example, we want to combine these inequalities into one compound inequality so that we will have a better idea of the relationship that exists between w, x, and y. To combine these two inequalities, notice that each one is comparing x with another value. Since x appears in each inequality, we can use this common term to combine the two inequalities. Now before we do this, please notice that both inequalities here are facing the same direction. This is very important, as we will later see. Okay, so first we'll line up the x's here. And now when we combine the two inequalities using x as the common term, we get the following relationship. So here we can see that the value of x lies between the values of w and y, and we can also conclude that w must be less than y. Now let's examine another example. Notice that in this example, we once again have x in both inequalities. Now if we line up the x's here, and then combine the two inequalities using x as the common term, we get a compound inequality where it is difficult to make conclusions about the relationship between w and y. So when it comes to combining inequalities, you will find it useful to first rewrite the inequalities so that they are facing the same direction. So in our previous example, we'll take the top inequality and leave it as it is. But we'll take the bottom inequality and rewrite it as y is less than x. Now that both inequalities are facing the same direction, we can see that w is less than x and y is less than x. Since both w and y are less than x, we cannot combine these inequalities into a compound inequality, which makes it impossible to compare the values of w and y. Okay, the next technique to examine is the technique of adding inequalities. The underlying principle goes something like this. If a is less than b and c is less than d, then if we add the two inequalities, it must be true that a plus c is less than b plus d. Now this property makes even more sense to us if we examine a real-world example. If Al has less than $15 and Bob has less than $10, then if we add Al's money and Bob's money, their combined wealth will be less than $25. Please notice here that both inequality signs are facing the same direction. This is a necessary requirement. In fact, before we add any inequalities, the inequality signs must be facing the same direction. So here's a quick example of this technique. Since 6 is greater than 1 and negative 2 is greater than negative 5, we know that when we add the two inequalities, the resulting inequality must be true. Now be careful to avoid taking this technique and applying it to the subtraction of inequalities. Now in some cases, if we subtract the inequalities, the result will hold true. However, in other cases, if we subtract inequalities, the result does not hold true. As such, there is no nice rule when it comes to subtracting inequalities, so avoid doing so. Similarly, you should avoid multiplying inequalities and dividing inequalities. This technique works only for adding inequalities. Okay, the next technique we will examine is best illustrated through the following examples. Since we know that x will always equal x, then we can also conclude that x plus 3 must always be greater than x for all values of x. To see why, let's examine x on the number line. To add 3 to x, we will move 3 units to the right on the number line to get x plus 3. Since x lies to the left of x plus 3 on the number line, it must be the case that x is less than x plus 3. In this manner, the number line can sometimes come in handy when tackling inequality questions. Please note that we can use similar logic to show that x minus 2 must be less than x. If we examine x on the number line, then x minus 2 will lie 2 units to the left of x. Since x minus 2 lies to the left of x on the number line, it must be the case that x minus 2 is less than x. Now let's combine some of our techniques to compare the values of y and w if we are told that y is less than x and x plus 5 is less than w. So given this information, what can we conclude about the relationship between y and w? Well, one approach is to first recognize that x must be less than x plus 5 for the reasons we just examined. At this point, we have x plus 5 in both inequalities. So now, if we line up the x plus 5s and then combine the two inequalities using x plus 5 as the common term, we can see the relationship that exists between w and y. We can see that y must be less than w. Okay, let's summarize. In this lesson, we learned that we can combine some inequalities if we first rewrite them so that the inequality signs are facing the same direction. We also saw that we can add inequalities once the inequality signs are facing in the same direction as well.